Welcome to March 5th LeetCode Challenge, Delete and Earn. You're given an integer array nums and you want to maximize the number of points you get by performing the following operations any number of times. Pick any number at nums I, index I, and delete to earn num at I points. Afterwards, you must delete every element equal to num at I minus 1 and every element equal to num I plus 1. Return the maximum number of points you can earn by applying the above operation some number of times. Alright, so how we go about doing that? So the first thing we want to delete is we want to delete I at, let's say, 4. Right? We delete I at 4, so delete 4 and earn 4 points. So 4, we want to delete, basically delete 3, because it's I minus 1, right? Which is the index before. So that will be 3. So consequently 3, and then you're left with the we'll draw it out. So first thing you want to do is delete 4. So when you delete 4, you want to you will also delete 3 as well, because it is a consequence of num I minus 1, which is equal to the 0, right? Equal to the 0th index. So you would do that, then you're left with 2, and then you delete 2, and then you get an empty array afterwards. So therefore, you delete you essentially get 4 points plus 2 points, right? Next thing you want to do is we'll go to example number 2 here, and you get this array here. So the first thing you want to do is delete the number 3 and earn 3 points. So say if you delete 3 here, each number num at minus I will be equal to 2, so delete all the 2's. And then num at I plus 1 is equal to 4, so you also delete a 4. So you're left with 3, 3. But keep in mind you have 3 in the bank here. So if you delete 3 here, there's no I plus 1, there's no I minus 1, larger or smaller than 3, so therefore you don't delete anything else, and then delete 3 again, that equals to 9. And that's pretty much it. So we're going to apply, this question is pretty similar to the famous house robber variation algorithm, or the house robber variation of it. Essentially, the story goes that you're like a professional robber and you want to rob houses, right, with have the most amount of money inside, and you basically don't want to rob, you want to maximize the money that you rob, right? And there's kind of a couple of conditions there. We have this condition, but it's kind of similar to that question. So the first thing you want to do is maximize the number of points. So we can do that by creating a dynamic programming array. I'm going to call this there you go, call it dynamic programming array, and that's going to be holding our points, and we're going to multiply that by the maximum number of our array nums plus 1. So that's a dynamic programming array. Right now it's empty, I'll populate with 0. So next thing we do is iterate through our numbers. So for nums, we want to find we want to update the dynamic programming array at nums and num, I should say, and then we want to increment that to a previous number. So this is what we're adding up. So that's our for loop, which is basically essentially iterate through each number in an array, and then we just sum them all together. So what we want to do now is develop 2 pointers, or 2 kind of dynamic 2 pointers basically. We're going to call this previous and prev and current. So previous is going to be at dynamic programming array index 0, and a current pointer is going to be dynamic programming array at index 1. And then what we're going to do is do for index I in the range of from 2 to the length of our dynamic programming array, we are going to update our current pointer and our previous pointer to the following. So we want the current pointer to be the maximum number we could take from the current pointer and the previous pointer plus 1, or plus the dynamic array at index I plus 1, index I should say. And then we want to update the previous pointer to the current pointer. And then once that loop runs, we could just return our current or output. Let's see if this is even resembling something. Yeah, I'm gonna call this current and previous. It just sounds much better. Current. There we go. And there's something wrong for I. Shift. This is I. Okay, let's run that. Most of it, I should say. Awesome. So ideally, this is kind of using a similar sliding window principle where you have 2 pointers, the current and the previous, keeping track of where you are in the index of the dynamic programming array, and then you just kind of find the max and then you add them all together, and then you just do the point system, right? That kind of follows through. Space complexity of the runtime is big O of n for linear time, and space as well. So space complexity and memory complexity are both big O of n, because where n is representing the maximum element in the array nums. Alright, there you go. Let's look at the hint here. Alright, that's it. Have a great day, guys.